Okay, guys, so let's go ahead and get started. So we're going to do section 7.2 today, basically, which is on normal distributions. So last class we talked about continuous random variables and the difference between discrete random variables and continuous random variables. Okay, so chapter 6, those were the discrete random variables. Discrete RV stands for random variables. And then chapter 7 is about continuous random variables. Both situations you can think of, you have a bag of numbers. When I say random variable, you need to think you have a bag of numbers, and you're going to put your hand in the bag and draw a number out of the bag. Okay, so that's the idea. But if you draw a picture of all possible numbers in your bag, if the picture looks a certain way, a bunch of dots with gaps, then it's a discrete random variable. That's again just a way of saying something about the bag. So the bag is a discrete random variable if all possible values of x, when you draw a picture, it looks like a bunch of dots with gaps in it. Continuous random variable, there's so many numbers in the bag that if you were to make a picture of all the numbers in the bag, you would not see individual dots. It'd be just like a whole range of values with no gaps in it. Okay. And last class we learned that when you're dealing with a continuous random variable, okay, so for a continuous random variable, when you want to find a probability, you have to find an area, okay, like this picture is showing you an area, okay. And so we learned how to do problems last class where we did two kinds of problems, right? The first one was I drew the curve for you and you had to just find certain probabilities and things by just looking at the curve and figuring out the area, where in that problem, the area was kind of labeled for you. The second kind of problem we did was uniform distribution. And when I say uniform distribution, then I'm telling you what the curve looks like without drawing it. Uniform distribution means the curve looks like a horizontal line. And then at the very end of last class, I just briefly talked about what a normal distribution is. Okay, so a normal distribution, which is what we're working on today, the curve looks like the curve that you're seeing in this picture over here. Okay, so it's going to always look like some kind of hill, and then the left and right side so the left side goes to the left forever, the right side goes to the right forever, gets closer and closer to the x-axis, never touches it though. Okay, so that's what a normal distribution looks like. But when we're doing a problem involving a normal distribution, you can't do the problem until you know which normal distribution it is, because there's lots of them, normal distributions, there's lots of them. How do you know which normal distribution we're working on? Well, you have to tell me the mean and the standard deviation first, and then once we know what those are, then we can do the problem. What problem? I'm saying, like, we want to find areas under normal distributions today. We want to find probabilities involving normal distributions, but I have to tell you these numbers first. So if I just say normal distribution, find some probability, you can't do it. But if I say we have a normal distribution, the mean is 10, standard deviation is 2, find some area, find some probability, then we can do it. I also mentioned at the very end of last class is there was one special normal distribution called the standard normal distribution. And for the standard normal distribution, the mean is 0 and standard deviation is 1. Okay, so you need to memorize that. So the plan for today, so we want to find areas under normal distributions, and we're going to do it kind of, there's going to be two separate sections to the lecture. The first section, which is going to be most of the lecture today, is we're going to be working on finding areas under the standard normal distribution. Okay, the word standard is very important, where the mean is 0, standard deviation is 1. Then once we get really good at doing that, then we're going to work on how do you find areas under normal distributions if they're not standard. Okay, so that's the idea. So we're going to find all sorts of areas today. Remember that for a continuous random variable, a probability is an area. So why am I trying to find an area? Because the area is giving me a probability. So what we're going to do, remember, the goal for the day is finding areas under normal distributions. But before we find the areas, we're going to do a quick warm-up. I feel like this really helps people understand the concepts of what we're going to do today. Okay, let's go ahead and get started. So what we're going to do is we're going to work on two things. First, notation, and then pictures. Okay, so what I'm drawing here is a standard normal distribution. Okay, so for everything we're going to do until towards the end of the lecture, it's always standard normal distribution. You can see it's a bell curve, so it looks like, oops, let me back up. Looks like a normal distribution. If I was to, draw this curve, looks like a normal distribution, so that's good. Notice the mean is 0. If you go from the peak down to the bottom, that's the mean. The mean is 0. Standard deviation is 1. I didn't label the standard deviation in the picture, but just assume that it's 1. Otherwise, I would have to find, the inflection point, and this distance here would be 1 kind of thing. Okay, but everything I'm drawing until example 8 basically is standard normal distribution. Now, there's an area there that represents the probability of something. Okay, so I'm going to want to write the notation for this. Okay, so let me explain how this is going to go. First of all, what's happening here? Where is the shading happening? There's this number 1.27, and the shading is happening over this section, this part of the number line. We're shading over this section. And what are these numbers down here? These are the numbers that are less than 1.27. Okay, so we're shading over the numbers that are less than 1.27. Okay, so this area represents a probability. The notation for the probability is going to go like this. So that area there is a probability. You're going to put a P and then a parentheses. Now, whenever the shading is happening to the left of a number or to the right of a number, you're going to put the letter Z first in the middle. Well, Z, we're using Z because it's standard normal distribution, but I want you to put the letter first. Let me say something else before we continue. So there's more than one way to write the notation for some of these things, but I'm going to teach you one way so that we're all doing it the same way. Okay, so whenever it's the area to the left of a number, you put the letter Z first. Then you're going to put a less than, and then you put 1.27. So why is this the right notation? Because we're shading over these numbers. These are the numbers that are less than 1.27. So think of it like this. We're shading over the numbers that are less than 1.27. One other way to say this is anytime we're shading to the left of a number, you put a less than here. Make sure you put the Z first, and then there's going to be a less than. So less than basically means we're shading to the left. Okay, so we're going to do 6 of them. I'll do, basically there's 3 types. I'm going to do 3 of them, and then I'm going to have you guys help me out with the other 3. So this time we're shading the area to the right of a number. See this area that's shaded here? So this shading is happening to the right of the number 2.9. Okay, so to write the notation for this, again, this area represents the probability of something. Sorry, this thing keeps changing slides on me. Okay, so this area is a probability of something. You're going to write probability because this curve is the standard normal distribution curve. We're going to be using letter Z. Put the letter Z first. Anytime it's the area to the left or to the right of something, since we're shading to the right, we're shading over which numbers? We're shading over these numbers. In other words, the shading is above these numbers. What are those numbers? The numbers that are bigger than 2.91. So we're shading over the numbers that are bigger than, greater than 2.91. That's the notation for that one. Okay, so anyway, if we're shading to the left of something, you put a less than here, and make sure you put the Z first. If we're shading to the right of something, put a greater than here, okay? And then the Z goes first over here. Any questions on that much? Okay, let's go to the third kind of problem. So here's another area. This is still standard normal distribution. That area is a probability of something. I want to write the notation for it. So notation goes like this. So it's going to be probability, but this is a little bit different. We're not shading to the left of a number or to the right of a number. We're shading between 2 numbers. You might say, Greg, we're shading to the left of 1.72. Yeah, the area that's shaded is to the left, but when I say area to the left, I mean area to the left, but it goes to the left forever. Okay, but this area it stops at negative 2.06. We don't go less than that. That's not the area to the left. Let me go back to the previous slide. This area is to the right of 2.91. And when I say it's to the right, I mean it's to the right forever. That shading goes to the right forever. And this other one over here, we're shading to the left of 1.27. The area goes to the left, but it doesn't stop. It just keeps going forever. You can't draw it going forever. Okay, so you have to stop at some point, but in your mind, you're thinking that area goes to the left forever. So area to the left, area to the right means goes forever, but this doesn't go forever. It's just between 2 numbers. When you're going to write that we're shading between 2 numbers, then you're going to put 2 less thans, and you're going to put the letter Z in the middle. Okay, and then the smaller number or the left number goes here. So negative 2.06, and the bigger number goes here. We saw something like this last class, but that's how you write between. Okay, so we're shading over which numbers? Over this section of the number line, which are the numbers between negative 2.06 and 1.72. make sure when you write between that these are both less than. Sometimes I'll see a student put a less than here, like here, and they'll put a greater than here. And they'll put the Z in between or whatever, and they'll put the numbers. But that makes no sense at all. Please don't write that. If you're writing between, it has to be two less thans. Okay, so you have to have a less than here, a less than here. Put the letter in the middle, so it's like the numbers are between these things. Smaller number goes there, bigger number goes there. And now someone might ask, because last class when we did these things, you saw less than or equal to, and this time we're just seeing less than. Okay, so the answer is like, do we have to put less than? Do we have to put less than or equal to? The answer is it doesn't matter. You want to put less than or equal to? That's okay. I'll take that. That's fine. It doesn't change anything, because what's the difference between me putting this and me just adding in this little line here? What's the difference? I'm saying I'm adding in the probability that Z could equal 1.72, but the probability that Z is equal to 1.72 is 0, because we learned last class that anytime it's a continuous random variable, those are the ones with curves like we have today. When it's equal a specific number in the parentheses, the probability is always 0. So if you put the line here, or if you don't put it, it changes the probability by 0. So it doesn't change the answer. So it's up to you if you want to put the less than or less than or equal to. It doesn't matter. I don't know why last time I put less than, I put the less than or equal to the whole time. And for all the stuff today, I'm going to just not put the equal to, but it doesn't matter. Pick whichever one you want. Okay, so this is called notation practice. Okay, so we're going to do some more of this. Here's a picture of an area. I want you to help me write the notation. Notation is very important. And when I'm grading, for example, this is a big part of it. And also it's going to help us understand things. So we really got to understand the notation. Okay, there's an area there. That area is the probability of something. What I want you to do is take a couple seconds to write down this area write down the notation for this area. And then I'm going to ask you to tell me one symbol at a time what the notation is. All right, someone tell me the very first symbol I'm going to write down for the notation.
P open parentheses.
Okay, keep going.
Greater or equal, greater than, I'm sorry, Z greater than negative 1.42 close parentheses.
Perfect, exactly. So yeah, anytime you're shading to the left or to the right, in this case, we're shading to the right of the number negative 1.42, put the letter Z first, okay? And again, since we're shading to the right, you're gonna put a greater than. You could memorize that when it's to the right, it's greater than, or you can memorize that these are the numbers that are bigger than negative 1.42. So we're shading over the numbers that are bigger than negative 1.42. Also, sometimes I had students tell me, oh, you could think of this symbol as like an arrow. So if we're shading to the right, that inequality is pointing, it's like it's pointing to the right. Now, that's fine. If any of you are thinking that way, it's totally fine, but you're only correct if you put the Z first. Well, the way I'm teaching you today, I'm making you put the Z first, so then that's fine. But if for some reason a student doesn't put the Z first, then that won't be correct, just so you know. Okay, any questions on this notation? Okay, here's another problem, another area. It's the probability of something. This is again the standard normal distribution. Take a couple seconds to write the notation down, and then I want you guys to tell me what the notation is. All right, someone tell me what the notation is for this one.
P parentheses.
P parentheses.
Z. Less than.
Right.
Negative 0.75.
Right, and then you close the parentheses. Exactly, perfect. Yeah. So again, it's an area, so it's a probability of something. This time, if you look at the picture, we're shading to the left. When you shade to the left, you're going to put in the parentheses Z first and less than the number. Yeah, it's like we're shading over which numbers on this axis over these numbers here. And those are the numbers that are less than negative 1.75 over the numbers that are less than negative 1.75. Again, another way to say it is the shading is we're pointing that way. So you see my little arrow sign, it looks like that sign right there. You can totally do that. As long as you put the Z first, then that'll be correct. Okay, let's go to the next one. This time, again, I'm giving you an area. It's a probability of something. This time we're shading between two numbers, okay? So someone give me the notation for this. So let me start it out. So it's an area. That means it's a probability of something. So you're gonna have probability of, okay. Now someone tell me what goes inside the parentheses.
1
1.53 less than Z less than 2.94.
Right, okay. So again, when you're shading between two numbers, put the Z in the middle, put less than's here, okay? And then yeah, the left number or the smaller number first, the right number or the bigger number second, yeah? Okay, so if I give you a picture, that's how I write the notation. Now we're gonna go the opposite way. Now I'm gonna give you the notation and you're gonna draw the picture. Draw a picture for this probability. So there's a probability. So when I draw a picture, I'm gonna draw an area of something. Because it says Z, I have to draw a standard normal distribution. So you start off by drawing like an x-axis. It's actually called the z-axis, but anyway. And then you draw some kind of bell curve like that. You're gonna put a dotted line here where the peak is, put the number 0 on the bottom, and you're gonna label it Z distribution. Okay, make sure for all the pictures you draw, you start off like that. Okay. Then the number that's in the problem is 2.83. Because it's positive, it's on this side, right? The positive numbers are on this side. The negative numbers are on this side. If the number is negative, you would put it on the left side of 0. Because it's positive, we'll put it on the right side of 0. How close to 0 does it need to be? It doesn't really matter. Just put a tick mark somewhere on the right side of 0. Put the number 2.83. Okay, then we're going to go from there up to the curve. And because it says less than, we're going to shade over the numbers that are less. We're going to shade to the left. The numbers that are less than 2.83 are the numbers to the left. You have to shade above the x-axis, below the curve, and to the left of 2.83. And how far to the left do you go? Forever. So all of this, you don't have, again, don't get too crazy, but just remember, at least in your mind, that that shading goes to the left forever. Okay, so that notation, that probability notation is this area, which I haven't taught you how to find the area yet. That's our next part of the lesson, but one thing at a time. So if I give you the notation, can you draw the picture of the area we're trying to find? That's the idea. All right, so that's the picture. Any questions on this picture? So here's the next problem. So let me go ahead and just draw the picture. So you draw a number line, you're going to draw a standard normal distribution. You put a dotted line here, put the number 0 here, label it Z distribution. Now the number is positive 1.59, so it's going to be on this side of 0 somewhere. On the right side of 0, put a tick mark, put the number 1.59. Then you go from the number 1.59 up to the curve. And which side do you shade? Well, because it's a greater than, it says Z greater than, you shade over the numbers that are bigger than 1.59. That means you go to the right. You're going to shade under the curve above the x-axis and to the right of the number 1.59. And how far do you go? In theory, it goes forever. I know you can't draw it forever, but just remember this area does go to the right forever because the curve goes to the right forever. But you know, you can't draw it going to the right forever, but it does. Okay, cool. So that's that one. Let's go ahead and try this next one. Okay, once again, I'm giving you notation for a probability. For a continuous random variable, probabilities are areas. I want you to draw the picture for this. So again, the way you draw it, number line, standard normal distribution. The dotted line here, put 0 there, and then put Z distribution here. Now, both these numbers are positive. If one of them would have been negative, you'd have to put on the left side of 0, but they're both positive. So 0.9 is somewhere on the right side of 0. 2.11 is positive, and it's bigger, so it's even more on the right. Okay, so you put 2 tick marks there, one at 0.9, 1.2, 2.11. And then you go up to the curve. So 0.9 up to the curve, 2.11 up to the curve, and then you shade between them. This is the notation for between. So you shade below the curve, above the x-axis, between these numbers. So picture should look something like that. Okay, so as we do the lecture today, notation is going to be very important. Not just as far as my grading goes, even though that's part of it. I'm going to definitely be grading notation, but also understanding the problem. Notation and pictures are going to be very useful. Okay, so any questions on If I draw the picture for you, you write the notation, or if I give the notation to you, you draw the picture. Any questions on any of that? All right, so what we're gonna do now is we're gonna learn how to find areas under these things. So we've drawn the picture, but how do you find the area? Okay, one thing I guess I should have mentioned earlier, let me mention it now. I'm gonna have to stop the sharing again real quick. Okay, so when we do the area stuff that we're about to do, we're gonna need to use a table. Okay, so I need to show you where to get the table. So give me a second here. Okay, so if you do everyone do this, okay? Go to my website, gregsriohondamathpage.com. You click on our class, and then you scroll down to where it says miscellaneous. Okay, so you go to our class, click on miscellaneous. Okay, so right there, and then you see up on top there's 4 tables. Okay, those are the tables that we're going to need for the rest of the semester. For the next few classes, we're only going to need the top table, but soon enough you'll need the other ones. So at some point, print them all out and have them in front of you. For example, on the quiz next time, on the exam you're going to have soon, you're going to need the tables. Okay, but for the up until chapter 8, you're only going to need the top one. So the one that says Z table, that's the one we need for today. So you should print that out. You don't have to print it out, but I advise you to print it out. Okay, so Z table. Okay, and again, if anyone missed it, let me just say it one more time. Go to my website, click on our class, scroll down, click on miscellaneous, and then it's the very top table that says Z table. Okay, so print that out and have that ready for what we're going to do today. You don't absolutely have to print it out, but I really think it's a good idea to print it out. All right, so now, how do you find probabilities involving the standard normal random variable Z? Or in other words, how do you find those areas that we've been drawing pictures for? I just had you draw the picture, but what is the area? How do you find it? Okay, so there's basically 3 types of problems. And you notice when we did notation practice and picture practice, we saw 3 kinds of problems. So there's gonna be 3 kinds of problems. So one of them is gonna be finding the area to the left of a number. One of them is gonna be finding the area to the right of a number. And another one's going to be finding the area between 2 numbers. So we have to learn 3 types of problems. Okay, and they're all pretty easy, but they're going to get a little bit harder as we go. So the first type is the easiest one, and then the third type is the hardest one, but none of them are really that hard. Okay, let's go and look at the first one here. So the first type of problem we're going to work on is find the area to the left of a number. Okay, how do you find the area to the left of a number? Well, here's the deal. We're trying to find the area under a curve, okay? Now, to be honest with you, that is a calculus question. That's one of the big concepts in calculus, finding areas under curves. Okay, but it turns out that, you know, like in calculus, when we give them problems and say find areas under curves, the curves we give them are usually pretty simple and the areas are not that hard to find. But when it comes to this curve, the standard normal distribution curve, the curve is just not so nice in the sense that you can't really, if you use the calculus techniques that we teach in calculus, you still won't be able to find the area under the curve. So what do? The answer is you can give it to a computer and a computer can calculate the area for you. Okay. So long story short, there was one guy, I like to say there was a guy who had no life and he calculated a whole bunch of areas like this and made a table. And that's what the table is. It's a list of areas. All we're going to use the table for, we're going to be like, hey, thanks, guy, for the guy who made the table. And we're going to be like, here's the table. You just look up the answer. That's all you're going to do. Actually, you're going to do one extra little thing, but that's the idea. So the table, though, let me make sure this is clear. The table is only to be used if you're trying to find the area to the left of a number. So the other 2 types get a little more complicated because the table is only designed to find the area to the left. So how do you find the area to the left of a number? You just use the table. That's what the table was made for. Okay, so we're going to do 2 examples. Let's start with example 1. Find probability Z less than 1.39. When you do this problem, you're only going to do 2 things. You're going to draw a picture. Please make sure you draw a picture for every problem. Okay, on the quiz next time, on the exam, on the final, I'm not going to tell you, hey, don't forget to draw the picture. But for every one of these problems, I want you to draw a picture. So there's a notation. We're going to draw the picture first. We're going to draw a number line. And we're going to draw a standard normal distribution above the number line. Dotted line here, 0, label it Z distribution. Okay, now it says probably Z less than 1.39 because the number is positive 1.39. It's on the right side of 0. So somewhere on the right side, put a tick mark and label it 1.39. Okay, then we're going to go up to the curve. And which side am I going to shade? Which side of that line? Left or right or what?
Left.
We're shading to the left because it says z less than, right? We're shading over the numbers that are less. Where are the numbers that are less? The numbers that are, they're on the left. The numbers that are less than 1.39. You're going to shade below the curve, above the x-axis, and to the left of the number 1.39, and you're going to shade to the left forever. All right, cool. So you make some kind of picture like this. I'm sorry, I take too long shading, so give me a couple seconds here. Okay, but you're going to shade something like that. So don't forget to shade. After you're done shading, the only other thing you're going to do is find the answer in the table. Now, when you look at the table, you'll notice there's two pages. The table has 2 pages. There's a negative side and there's a positive side. Okay. Because the number we're going to look up is positive. Okay, this number is positive 1.39. You can use the positive side of the z table. So again, you only do 2 things. Draw the picture, look up the number in the table. Here's the positive side of the z table. Let me just show you real quick. Notice all the numbers here in the left column are positive. Let me go forward a couple of slides real quick. This one, all the numbers in the left column are negative. So you pick the page you need. We need the ones that have positive numbers here because the number we're looking up is a positive number. So we'll go back. The number we're looking up is 1.39. So here's what you do. Here's a table. I'm going to write down the number we're looking up, 1.39. Notice this number has 2 digits after the decimal. Every problem involving z distribution is going to have 2 digits after the decimal. So how do you look it up? Well, what you're going to do is you're going to ignore the last digit for a second. So let's ignore the 9. Okay, let's just look at the 1.3 part. You can look for the 1.3 here. And here it is right here, 1.3. Okay, you're going to get the last digit from the top. So everything up to the first digit after the decimal, you get out from the left. And the last digit you get from the top. The last digit is 9, basically 0.09. Okay, so that's 1.39 there. From the 1.3, you're going to move to the right. You can draw a line to the right. From the 0.09, you're going to go down until these 2 lines I'm drawing cross, or until they meet. And it looks like they're meeting at this number, and that's the answer. 0.9177 is the answer. We write it in red here. That's the end of the story. All I'm really teaching you for this kind of problem is how to look it up in the table. Okay, so that's how you look it up in the table. Okay, so when it's a less than, okay, first of all, always draw the picture. Then, when it's a less than, you just look it up in the table and you're done. Any questions on example 1? Okay, let's go ahead and look at example 2. All right. Again, it's a less than, probability z less than something. First thing you're going to do is you're going to draw a picture. So, number line, standard normal distribution. Put a 0 there, put a z distribution here. But this time the number is negative. Because it's negative, it's going to be on the left of 0. So somewhere on the left side of 0, you're going to put a tick mark and label it 0.87. Okay. Then you're going to go from that number up to the curve. And which side am I going to shade? The left of it or the right?
The left.
Left. Because it says z less than a number. The less than is telling you shade to the left. Okay? And so you go under the curve above the x-axis to the left. You go to the left forever. I mean, you're not going to draw forever, but the idea is it goes forever to the left. So you draw this picture. Okay, then if it's an area to the left problem, like it is here, it's real easy to find the answer. You just look it up in the table. But because the number is negative, you have to use the negative side of the z table. So here's the negative side of the z table where there's negative numbers here. I forgot what number we're looking up already. Let me go back. Negative 0.87. So we're looking up the number negative 0.87. Again, notice there's 2 digits after the decimal point. That's always going to be the case. So we'll ignore the last digit. We'll look for this part first. Negative 0.8 on the left column. It's right here, negative 0.8. Then you get the last digit, the 7 from the top. That's right here. It's 0.07. Okay. Then you're going to go from the negative 0.08 to the right, like this. Then you go from the 0.07 down until these two lines meet. It looks like they're meeting at the number 0.1922. Okay, so that's the answer, 0.1922. Okay, so that's all you do. Draw a picture, and look it up in the table. But again, you only do that when it's an area to the left. The table was made to look up areas to the left. So if it's not area to the left, you don't do it this way. But first things first, let's make sure we know how to find area to the left. Any questions on example 1 or example 2? Here's example 3. Again, it says probability z less than. So when it says probability z less than something, we're always finding the area to the left. And that's when you use the table. The table is only for areas to the left. Once again, we're going to draw a picture first. So number line. Draw some kind of bell curve. From the peak, go to the bottom, put a 0 here. Label it z distribution. Okay, so that's the standard normal distribution. Now the number in the problem is negative 2.03. It's negative, so it goes on this side somewhere. So somewhere on the left of 0, put a tick mark and put negative 2.03. And then you're going to go from that number up to the curve. And which side are we going to shade?
The left.
To the left. Again, it's because it says z less than negative 2.03. You're shading over the numbers that are less than negative 2.03. Those are the numbers that are on the left of negative 2.03. So you draw a picture, it looks something like this. Again, on the exam and in the future, please don't forget to draw the picture. Then, because this is the area to the left of something, the good news is you can just look it up in the table and that's it. So we got to look up negative 2.03 in the table. Again, because the number is negative, you're going to use the negative side of the z table. Once again, this is always going to be the case. The number you look up will always have exactly 2 digits after the decimal. The way you look it up is you look up you ignore the last digit, you look up the rest on the left column of the table. So you look up negative 2.0. Here's negative 2.0. Then you get the last digit, the 3, from the top. And again, you're going to go to the right here, and you're going to go down here until these two lines meet. It looks to me like they're meeting at the number 0.0212. So the answer to, so that's how you look that up. The answer to that one, 0.0212. And that's example 3. Questions? Now let's go to the next kind of problem. How do you find the area to the right of a number? Okay, so it's a little more complicated. As far as your work goes, you're going to have to do a couple, like maybe 2 extra steps, because you're going to have to write down some kind of formula. So first thing I'm going to do is I'm going to explain where this formula came from. I want to make sure you guys understand it, but then you'll memorize it. Okay, so memorize the formula. It's not very hard, but I want you to first see why it's right, then use the formula, and then do the thing. All right. So this says to find the probability to the right of a number. How do you find the area to the right of a number? You don't just use the table. The table's only made to find areas to the left. How do you find the area to the right? Well, here's what I wrote here. It's not as easy, but it's still pretty easy. Just a little bit extra work. You're going to turn it into a probability to the left with complements. Look what it says here. Turn it into probability to the left. We know how to find areas to the left. How do you find the area to the right? Turn it into a problem involving area to the left. We have to do that because we only have the table. And the table only gives us areas to the left. So if a problem is not area to the left, your job, turn it into an area to the left problem. So that way we can use the table because that's all we have. All right, so everybody check this out here. You're not going to draw all of this stuff. I'll show you when we do an example what you need to draw. All you need to do is draw a picture for the original question, but I am drawing some extra stuff here so you can understand why this, the formula I give you is going to be correct. So take a look at this picture. I'm trying to find the red area, the probability z greater than 1.14. The red area is the area to the right of 1.14. But what I did is, besides the red area, I also shaded the area to the left of 1.14 in blue. I don't want the blue area, I want the red area. And you're not going to even shade the blue area, but so I just want the red area. But I shaded the blue as well. Now I have a question for you. Okay, so if you know the answer, please say the answer. What is the blue and red area total? The total of the blue and red, what is it?
1.
It's 1, exactly. Because we learned that for continuous random variable, the area under the whole curve has to be 1. And the blue and red combined, I've shaded everything under the whole entire curve. So the blue and the red total are 1. Okay, that's what it says right here. I wrote the notations. This is the blue, probability z less than 1.14, that's the blue area, plus the probability z bigger than 1.14, that's the red area, has to equal 1. Which one do I want? It's this one that I want. I want the probability z bigger than a number. I want the red one. So what you do is you just basically subtract this over, and you're going to get 1 minus this thing. So probability z greater than 1.14 is 1 minus probability z less than 1.14. So if, again, you're just subtracting this whole entire mess on both sides. You get 1 minus this. Okay, so that's like a formula you're going to memorize. So before we continue with this example here, anytime you have a greater than problem, I'm going to be looking for this formula. So memorize it. This is what you do. Anytime it's probably z bigger than a number, you're going to write 1 minus, and then you're going to write probably z less than the same number. This notation here and this looks exactly the same, except it was a greater than here, it's a less than here. Okay, so anytime it's probability z greater than a number, 1 minus probability z less than the same number. Now, after you write this formula, this is great. Why is this great? Because this part here is a less than. I can look that up in the table. The table is made for less thans. The area to the left, the less than is this area that's in blue, which is the area to the left of 1.14. That's what the table is made for. So you turn a greater than problem into a less than problem, there's going to be a 1 minus in the front. But then the less than part you look up in the table. So when you look that up from the table, it's 0.8729. Don't forget to write the 1 and the minus though. And you do 1 minus that, and that's the answer. So basically the red area and the blue area are complements. One of the areas is 1 minus the other one. So the red area is 1 minus the blue. Why do I go through the trouble of writing it like that? Because the blue area I can look up in the table. So how do you find the red? 1 minus the blue. Okay, so that's the idea. Now let's go ahead and do an example so you can see what I want you to do. So first thing you're going to do is draw a picture. Okay. Now, if it ever gets complicated and you're wondering which picture should I draw, because maybe there's lots of different notations, you're always going to just draw a picture for the very original question. So the best thing to do is draw it first before you do anything else. So I'm drawing standard normal distribution, putting a 0 here, labeling it z distribution. The number is negative 1.77 because it's negative, it's on the left of 0. So it doesn't matter exactly where, just put it somewhere on the left side of 0. Then go from there up to the curve. And because it's probability z greater than negative 1.77, which side do I shade? The left of this line, of the red line, or the right of the line?
The right.
The right. You shade to the right forever. I mean, you go to the right forever. Okay. So that's the picture for the area that we're looking for the probability that we're looking for. Okay, so again, always draw the picture first. After you're done drawing the picture, the next thing you're going to do is you're going to use a formula. We can't use the table yet until we use a formula because the table will not give us a greater than probability. It only gives us a less than probability. So now you write a formula. Okay, the formula goes like this. Every time it's probability z greater than something, you're going to write 1 minus. Okay. And then who could tell me the rest that I'm going to write? Someone tell me the rest.
The probability of z less than negative 1.77.
That's right. You write basically this exact thing down, just change the symbol to a less than. Leave the number negative. You don't change the number, you just change the greater than to a less than. Yeah. Probability z greater than negative 1.77 is 1 minus probability z less than negative 1.77. That's a formula. Memorize it. You don't have to draw the picture like I did in the last slide. That picture in the last slide was so you can believe the formula. Okay, but just memorize that formula. That's what you do when it's a greater than. Okay, then this less than, it's a less than, you can look that up in the table. You don't need to draw a separate picture for this. Just look it up in the table. So remember, less thans or area to the left, those are the ones you use the table for. It's negative 1.77, so let me go get the negative side of the z table. We're looking up the number negative 1.77. Again, we'll work on the first 2 digits. Here it is, negative 1.7. And the last digit, 7, we're going to get from the top. There it is. So this and this combined are like negative 1.77. Okay. Then you go from the negative 1.7 to the right. You draw a line like this, 0.07 down until these lines meet. I mean, you don't have to draw these lines, but just imagine, follow them until they meet, and we get that number, 0.0384. Now, that's not the answer to the question. 0.0384 is the answer to this part. 0.03, I already forgot if I copied it. Let me see if I copied that right. 0.0384. Yeah, that's right. Okay. And then you do 1 minus that. So you got to calculate 1 minus that, and the answer is 0.9616. Okay, so it's 2 extra steps. You write the formula. This part you have to look up on the table, but then you have to do 1 minus that and get your answer. So instead of writing one thing, just writing the answer, you got to do 2 other little things. That's example 4. We're going to do one more like this, but any questions on example 4? Okay, so example 5. Example 5, probably z greater than 0.18. First thing I'm going to do, draw a picture. Number line, z distribution, dotted line here, 0, label it z distribution. Okay, so you always start off with a picture like that when it says z. Now, the number is 0.18, it's positive, so it's on the right side of 0. So somewhere on the right of 0, I'm going to put a tick mark. I'm going to label it 0.18. Then we're going to go from that number up to the curve. And which side of this line am I going to shade, to the left or to the right?
The right?
Mm-hmm. We're going to shade to the right because it's a greater than. When it's z greater than, you shade over the numbers that are bigger than 0.18. Where are the numbers that are bigger than 0.18? They're on the right of it, so you shade to the right. Under the curve, above the x-axis, to the right of 0.18, forever to the right. So you draw that picture. Okay, next thing you do, again, when it's a probably z greater than something, you're going to write a formula. All right, someone tell me the formula.
1 minus p z less than 0.18.
Exactly. When do you use this formula? When it's a greater than problem. Okay, it's got to be probability z greater than something. Or when it's an area to the right, that's when you have to write the formula down. Please don't forget the formula when I'm grading. It's part of the grading. Okay, so I'm like, okay, did they write the formula? Did they look up the number correctly? Did they get the answer? Did they draw the picture? You know, all these things. All right, after you write down the formula, I'm going to copy down the 1 and the minus, but this part here, the less than, when you have a less than, you can just look that up in the table. That's what the table is for less than probabilities. So I have to look for 0.18 in the table. Since it's positive, use the positive side of the z table. We're looking for the number 0.18. We're going to find 0.1 right, where is it? 0.1 right here. And then the last digit, the 8 or 0.08, we're going to get from there. So you're going to go to the right like this and down like that until these lines meet. Looks like they meet at 0.5714. That's not the answer, but that's the answer to the less than part, 0.5714. That's what goes here, 0.5714. They just do 1 minus that. And we do 1 minus that, you get 0.4286. That's example 5. That's how you do greater than problems. Any questions on greater than problems? Now, don't forget, everything up until the next 2 examples we're going to do, they're all standard normal distribution problems. So you only do the stuff we're learning today with the table and all that if it's a z problem, okay? Standard normal distribution problem. Okay, so we learned how to do 2 types. The area to the left, you look up in the table. Area to the right, use this 1 minus formula, and then you're going to look up this part of the table, and then you'll do 1 minus that answer. So the third type now, how do you find the area between 2 numbers? Okay. That's the hardest one, but it's still not hard. I'm basically going to give you another formula to memorize. If you memorize the formula, you're great. But before we memorize it, I want to show you where it comes from so it makes sense to you. Okay, so to find probability between 2 numbers, what are you going to do? It's the most difficult one, but it's easy still. They're all easy once you get it. You're going to turn it into a difference in 2 probabilities to the left. Okay, so everyone check this out. I want you guys to focus for the next couple minutes as hard as you can. Okay, not that you're not focusing hard already, but focus really hard because I want to make sure this makes sense. I'm going to draw a bunch of pictures here. You're not going to draw them all, okay? I just want you to see the logic behind the formula that's coming. So pretend that's the area I want to find, okay? The one that's in that picture there. I want to find the area between negative 0.41 and positive 1.89. The problem is I can't use the table right now because I can only use the table if it's area to the left of something, okay? You might say again, that's the area to the left of 1.89, but it's not to the left forever. See, this part here is not supposed to be shaded. So it's not the area to the left. So here's the trick. Here's what I'm going to do. Besides the red area, which is what I'm looking for, there's two unshaded areas. There's two areas that are in white there, okay? In other words, there's this part here, and then there's this part here. What I'm going to do is I'm going to shade the left side, the left one. I shade it in yellow. Let's take a look at this picture, the middle picture here. So as far as this picture goes, if I found the area of everything that's shaded, the bad news is that's not the answer that I want. I want the red area. Okay, if I found everything that's shaded total, it would be too big. Okay, because it's the red area plus there's more area in there. So the bad news about the middle picture is everything that's shaded total is not the area I want. That's the bad news. The good news is if you just look at everything that's shaded total, that's the area to the left of 1.89 now. It's to the left of 1.89 forever because it goes to the left. When you get to negative 0.41, you keep going because the rest of it's still shaded. It's shaded a different color, but it's still shaded. So good news about the picture in the middle, I can look up that answer. It's the area to the left of 1.89. But again, what's bad about this area is it's too big. It's not the answer I want because I only want the red. I don't want the yellow in there. So what I'm going to do then is I'm going to look at just the yellow by itself. Here's the yellow by itself. And there's some good news about the yellow area. The good news about the yellow area is that it's also the area to the left of something. Okay, the yellow is the area to the left of the number negative 0.41, and I can look that up in the table. So let's go through that again. The red area, which is what I'm looking for, well, here, it's equal to the red and yellow total, but well, okay, the red and yellow total is too big. So it's like I put the yellow in there, now it's too big, and then what I'm gonna do is I'm gonna take away the yellow area. So I wanna make sure you guys understand that. So the red area is the red and yellow total minus the yellow. Seems a little silly why I would just put the yellow in there and then take it away. But the reason I'm doing that is because I don't know how to find this. I'm trying to figure out how to find this. But this I can find. That's the area to the left of 1.89. And this I can also find. This is the area to the left of negative 0.41. So we could find this area in the table, find this area in the table, and then subtract them, and we'll get the area we want. Okay, let me go through that one last time here. So again, I'm trying to find the red area, which is the area between negative 0.41 and positive 1.89. So what you do is you throw in some more area, throw in the yellow. The red and yellow total is too big, but then if you take away the yellow, you would get just the red area that you want. So the red is the red and yellow total minus the yellow. But again, this one here is the area to the left of 1.89, so I can look that up in the table. This is the area to the left of negative 0.41, so I can look that up in the table. Then you subtract them. Now what I want to do is, like we did earlier today at the beginning of class today, I have pictures here. I want to write the notation for the areas that you see in the pictures. Like the notation for this area is probability Z between negative 0.41 and 1.89. So we'd write it like that. Someone tell me the notation for this middle area. When I say middle area, I mean the yellow and red area total. Someone tell me the notation for that area.
Probability of Z less than 1.89.
Yes, probability less than 1.89. Then I'm going to copy down the minus symbol, and then someone tell me the area here that's just in yellow. Notation for it.
Probability of Z less than negative 0.41.
Right. Okay, cool. So this is basically a formula, okay? Where did it come from? The picture showed me that it's correct. You're going to memorize it because I'm not going to have you draw all these pictures. You definitely do not need to draw all those pictures. But I'm drawing them for you so you can see where the formula comes from. But you're going to go ahead and write down this formula. So you memorize this formula. Okay. Here's how I want you to say it to yourself so it's easy to remember. When you find the probability Z between two numbers, The first term is going to be probability z less than the number on the right. Probability z less than the right number minus probability z less than the left number. Make sure you understand these two terms are both less thans. That's the whole goal. Take whatever problem you have and turn them into less thans, because when they're less thans, you can look it up in the table. Please make sure you remember these are less than. Sometimes I'll get a student who will stare at this and try to come up with this from this, which is not possible to do. Okay, where did this stuff come from? The pictures is the reason why it's correct. Like, okay, a student might say, you know, oh, look, it says z less than 1.89. It says z less than 1.89. Okay, I see that. But then they might go, okay, for the other one, we'll just look at this part. But this thing that I'm boxing here and this other thing that I'm boxing here are not the same thing. This one, basically, the z is not written first. But if you were to write the z first, it would be z greater than negative 0.41. But this says z less than. Which one is correct, greater than or less than? Answer, it's supposed to be less than. These are both supposed to be less thans. Again, it's coming from the pictures, okay? So I'm hoping you understood the picture so you can understand where this formula came from. But again, when you do the problem, just memorize it. Memorize it like this. When you find the probability z between two numbers, it's going to be probability z less than the one on the right minus probability z less than the one on the left, okay? Probability z less than whatever number you see on the right minus probability z less than whatever number you see on the left. Once you've memorized that, then we're in good shape because now each of these can be looked up in the table because they're less than. So we look them up in the table and we subtract them, and then there's the answer. Okay, we'll do a couple of examples. Any questions so far? All right, let's move on. So example 6. Again, we're always going to draw a picture first. Probability z is between 0.28 and 2.17. First picture. This is standard normal distribution. You put a 0 here. You're going to label z distribution. Both numbers in the problem are positive, 0.28, 2.17. So put them both on the right side of 0, 0.28, and go a little further and put 2.17. From 0.28, you're going to go up to the curve. From 2.17, you're going to go up to the curve. You're going to shade between. This is a between probability. So make sure you shade this area. Okay, then next thing we're going to do is you're going to apply the formula. All right, someone help me out with the formula. What's the first? Just tell me the first term.
P open parentheses z less than 2.17.
Right. Probability z less than whatever number you see on the right side over here. Yeah. Okay, then it's going to be minus. Now tell me the term that goes here.
P parentheses z less than 0.28.
Right. Perfect. So the second term is going to be probably z less than whatever number is on the left over here. Probably z less than the right number minus probably z less than the left number. So again, please don't forget that formula. I'm going to be looking for it. Then to continue, let's look up this number. You can look up this number in the table now because it's less than 2.17. It's positive. We use the positive side of the z table. 2.1 is here. The last digit 7 is here. And you go like this. And that probability is 0.9850. That's this one here. So this one here is 0.9850 minus. Now we're going to look up this one. Again, it's a less than, so you can look it up in the table now. Positive 0.28. Because it's positive, use the positive side of the z table. Erase this. I already forgot what it was. Was it 0.28? I think that's what it was. Let me double check. Yeah. Okay. 0.28. So you're going to look for the 0.2 here and last digit here. And then you go to the right on the 0.2 and you go down on the 0.08 until the lines meet. Looks like they're meeting at 0.6103. That's this answer. And then you subtract those. I'm getting 0.3747. And that's exactly the work I want to see. Okay, so picture, formula, look up each number, and then subtract them. We'll do one more like this. Any questions on example 6? All right, let's go to example 7. This time, both of the numbers are negative. That means they're both going to be on the left of 0. But sometimes one is negative one time and the other one is positive. So whatever the numbers are, if they're negative, put them on the left side of 0. If they're positive, put on the right side of 0. But okay, so picture first, number line, standard normal curve, 0, label it z distribution. Okay, so negative 2.33, it's negative, so it's on the left of 0. Negative 1.04 is still on the left of 0, but closer to 0. So you put 2 tick marks, label those numbers. Then you're going to go from each of those tick marks up to the curve. And because it's a, the notation's like that, it's a between problem. When you have 2 numbers and z in the middle, it's a between problem. So you shade between the 2 numbers. Below the curve, above the x-axis, between the 2 numbers. You don't go to the left forever, the right forever. You just go between these 2 lines that are drawn. This one here and this one over here. All right, so you draw the picture first. Then we're going to apply the formula. So once again, guys, help me out with the formula. What is the first term of the formula?
Would it be P open parentheses Z less than negative 1.04?
Right. Keep going.
And then minus P open parentheses Z less than negative 2.33.
Right. So once again, memorize it as probability z less than this minus probability z less than this. Make sure you also put it in the right order. So the negative 1.04 has to be written first before this. Okay. Probability z less than the number you see on the right minus probability z less than the number you see on the left. After you write that formula down, you look up each of these. We'll look this one up first because it's a less than. You can look it up in the table. But because it's negative, you use the negative z table, negative 1.04. Let me write it here, negative 1.04. So you're going to get the negative 1.0 from here, and the last digit, the 4 from here. Negative 1.04. Okay, so you go to the right here. You're going to go down here until the lines meet. Looks like they meet at, oh, my line's gone. Anyway, 0.1492. That's this number here, 0.1492. Minus. Now we're going to look up this number. Again, it's a less than. You look it up in the table. Negative 2.33. Use the negative side of the z table. So now we're looking for negative 2.33. Okay, negative 2.3 is right here, and the last digit 3 is over here. So go like this to the right. Go down here. And the answer to that one is 0.0099. That's what goes here. And then you subtract those. And when you're done, 0.1393. And that's example 7. Any questions on example 7? Okay, guys. So now I'm going to assume that you are experts at finding areas under the standard normal distribution, the stuff that we just learned. Now we're going to, how do you find areas under other normal distributions, not the standard one? Remember, the standard normal is the normal distribution where the mean is 0, standard deviation is 1. But now we're going to look at how do you find areas under other normal distributions where the mean is something else, standard deviation is something else. So then how do you find these areas? Now let me just tell you the answer real quick. It's just an extra step in the problem, one more step. What you're going to do is any normal distribution problem, you're going to convert it to a standard normal distribution problem. And that's the idea. So first step, change it to a standard normal distribution problem. I'll show you how to do that. And then it becomes a problem like the stuff we did before the break. That's why you got to be really good at that stuff. Then you just add one extra step to it. So let's go and read this here. Finding probabilities for the random variable x if x is normal but not standard normal. It's not standard normal. What do you do? If the random variable x has a normal distribution with mean, mu, and standard deviation sigma, but doesn't have the standard normal distribution, what you do is you turn it into a standard normal distribution problem by using something called a z transformation. You're going to use a z transform. You transform it to a z problem. And here is the Z transformation formula, Z equals X minus mu over sigma. Okay, this formula here is really important in stats, and it shows up in a lot of different places. There's one place it showed up in chapter 2 that we skipped. If had you read that stuff, then you might have seen this formula before. We're going to use it here, and it's going to show up again in future chapters. So this formula has lots of applications. For right now, what we're using it for is the following. To do a Z transformation. So what you're doing is we have our variable X, and what you're going to do is you're going to, so you have to memorize this. You're going to minus mu and divide the whole thing by sigma. So what I just said, minus mu, and then divide everything by sigma. I want you to memorize that. When you take whatever your original question was and you minus mu and you divide everything by sigma, it turns it into the Z random variable. So I'm not going to say much more than that, but I want you to memorize this little thing here. Minus mu, divide everything by sigma. And that turns a normal problem into a standard normal problem. That's what it does. Okay, so let's go ahead and look at some problems. We're not going to do an actual example yet, but let's look at a picture here. So here's what I'm trying to draw here is a normal distribution that's not standard. So I'm not putting the number 0 there, okay? But it's still, all normal distributions look like this, okay? And I'm trying to find the area to the left of the number A. The notation would be probability X less than A. What we did before the break, it would have been probability Z less than A, since we're doing to the left of A. But if it's not the standard normal distribution, if it's just any old normal distribution, we're going to use the letter X. That's the notation for that area there. Now, if I'm trying to find this probability, here's what you're going to do. Basically, what you do is the following. You copy down the P symbol and the parenthesis symbol and the less than symbol, okay? And then notice there's two blank spaces. There's a space here and there's a space here. You have to change what's written in those spaces. What was originally in the spot here before the less than? Originally, there was an X. What you're going to do is you always copy down what was originally there, and then you do the Z transformation formula. So you copy down the X, and then what do? You minus mu and divide the whole thing by sigma. So that's the new thing you put in that spot. Now let's go to this spot. What was originally there was the number A, okay? So you copy down you always put what was originally there, you put it there, and then you do minus mu, you have to memorize this, minus mu, and divide the whole thing by sigma. Okay, that's called the Z transformation. When you do that, so we're here now, once you've done that, this part here, the part that originally had the random variable X, that whole mess will turn into Z. This whole mess is just Z. So now it becomes probability Z less than A minus mu over sigma. Okay, so that mess turns into Z because that's the formula from the previous slide. Let me just show you, right? So if you have X minus mu over sigma, you just change that whole mess to Z. Now the thing on the right side over here, don't worry about that. Those are just a bunch of numbers. So you'll calculate that, that'll be a number, and it'll be probability Z less than a number. And now you do the Z problem. So what happened is we started off with a normal distribution problem, and we did this, and now we have a standard normal distribution problem, and then you do the standard normal distribution problem. So that's a Z transformation. You just transform it from a normal distribution problem to a standard normal distribution problem. Let's go and look at the other types. So let's say it was this. This is the area to the right of a number. Again, this is a normal distribution, not the standard normal distribution. So the notation, instead of it being probability Z bigger than whatever that number is down there, instead of using Z, I'm going to be using the letter X. So the notation for this area is probability X greater than A. And I want to change it so that it involves Z. You want to transform it to a Z problem. So what you do is, again, you copy down the parentheses symbol, you copy down the P symbol, you copy down the parentheses symbol, and you copy down the greater than. And that leaves two spaces inside the parentheses you have to fill in. And what do you put in those spots? Well, you put what was originally there. Originally in the left spot here, there was an X. You're going to write that in there. And then you're going to minus mu and divide the whole thing by sigma. That's what you do. Minus mu, divide the whole thing by sigma. You do that for each part. For this part here, for this space, what was originally in that spot was this number here, whatever A is. So you'll write that down, you'll copy that down, and then you'll minus mu and divide the whole thing by sigma. Again, that's the Z transformation formula. So you get that. And now, after you do that, the part that had the X in it, this whole X minus mu over sigma business, that turns into Z. And again, this other part just ends up being a number because all A, mu, and sigma are all just numbers. And it becomes a Z problem. So again, you transform an X problem, a normal problem, into a standard normal problem. Before I continue with the third one, let me make sure you understand, you only do what I'm teaching you now if the problem is normal. The problem has to say your random variable is normal. If it's anything else, like uniform or whatever, you don't do this, okay? It's only if it's normal, then you transform the problem into a standard normal, and then do the stuff we learned. So if it's normal, change it to standard normal. So change it from X to Z, and then you do the Z problem. The third kind of problem is if we're trying to find the area between things. The notation, if this was a standard normal distribution problem, we would have wrote this. Probability Z is between these two numbers, A and B. But again, this is not a standard normal distribution problem. This is just any other normal distribution problem. So we're going to use the letter X there. So that is a notation for the question. Now, it's a normal problem, but not standard normal. So we want to change it to a standard normal. It's an X problem. We want it to be a Z problem. So we're going to transform it. How do you transform it in this situation? Well, again, you copy down the P symbol, you copy down the parenthesis symbol, and you copy down the two less than symbols. And for this one, notice there's 3 spaces. You got to fill in all 3 spaces. You got to do the Z transformation to all 3 of those parts. When you look at this first space over here, what do? Well, you look at what was originally in that spot, which was A. You're going to write down A. Then you're going to minus mu and divide the whole thing by sigma. You memorize that. First copy whatever was down, copy what was originally there first, then minus mu and then divide the whole thing by sigma. For the second part, what was originally there was an X. You're gonna copy that down, then you're gonna do minus mu and divide the whole thing by sigma. For the third piece, again, same thing. Copy what was originally there, B, then you're gonna minus mu and divide the whole thing by sigma. So you get that much. Once you have that, the part that has the X, so this whole X minus mu over sigma, that part turns into Z. And the other 2 parts are basically just going to be numbers. So when we do the problem, this will be some number, this will be some number. But the point is we turned a normal problem, a normal distribution problem, into a standard normal distribution problem. And then we can do the problem the way we did, because we can calculate the standard normal distribution stuff from the stuff we learned before. Okay, so that's what you do. So again, whenever your variable is normal, you're going to change it to standard normal by doing the Z transformation. And then you do the standard normal problem, and then you'll have your answer. So it's just one extra step. So again, if you're good at doing standard normal problems, if it's normal but not standard normal, what do? You change it to standard normal, then do the standard normal problem. That's it. So let's look at a couple of examples. I know maybe it's a little bit hard with all these symbols and stuff, but let's look at a couple of examples here. All right, suppose X has a normal distribution with mean 30 and standard deviation 7. Okay, it's very important they say it has a normal distribution, otherwise you're not going to do what we're going to do. But X is normal, and if it's normal and not standard normal, they have to tell you the mean and the standard deviation, otherwise you're not going to be able to do the problem. If it's standard normal, we know the mean is 0, standard deviation is 1. But if it's any other normal, like here, this variable is normal, they have to tell you what the mean is and the standard deviation. They told us that, and now they're asking us to find all these probabilities. All right, let's start with the first one. Probability X less than 35. Don't forget that a random variable is a bag of numbers. So what they're trying to say here is there's a bag of numbers, and the fact that they say it has a normal distribution with mean 30 and standard deviation 7, they're trying to describe the contents of the bag somehow. Like they're trying to give you an idea of what numbers are in the bag. That information lets you know pretty much anything you would want to know about the bag. And now this is saying, if you draw a number out of the bag, what's the probability you get a number less than 35? Okay, remember, we always have, anytime we're talking about random variable, there's a bag of numbers, we're going to draw one number out, that's what X is. What's the probability that the number we draw out is less than 35? That's the question. So if the contents of the bag are the way we have it described here, and you draw one number, what's the probability you get a number less than 35? Okay, so that's what's going on. Now, in order to do this problem, the first thing you can do is you're going to draw a picture. So you always draw one picture for the original question, and that's it. This is a normal distribution. The picture changes a little bit. Check it out. I'm not going to put the number 0 here. You have to put what the mean is. For standard normal distribution, put 0. But what number am I going to put for this problem?
30.
30. Because the mean is 30. That's what it says. Mean is 30. Oops, where is it? Yeah, right here. Mean 30. Okay, so 30 goes in the middle. Okay, and then you could label it X distribution instead of Z distribution because, you know, it's not the Z distribution. All right, now let's keep drawing the picture. So the number that's in the problem is 35. Because 35 is bigger than 30, you put it on the right of 30 somewhere. Put a tick mark, put 35. Go up to the curve. And now, which side am I going to shade? Look at this. It says probably X less than 35. Which side of 35 am I going to shade?
The left.
The left. Yeah. Because it says less than 35. You shade over the numbers that are less than 35. The numbers less than 35 are on the left of it. And again, when you shade to the left, you shade forever to the left. Under the curve, above the x-axis, to the left of 35 forever. And again, no matter what we do in the rest of this problem, I don't need any other pictures. I just always want to see a picture for the original question, and that's it. All right, so there's the picture. Any questions on the picture? Okay. Now, the next thing we're going to do is because X is normal, we're going to change it to standard normal, which with a Z transformation. What you're supposed to do is supposed to write Z transformation above the equal sign whenever you do a Z transformation. Now you might be like, oh, it's another one of those things he makes us write. But actually this is standard. Everyone pretty much makes you write that. Whenever you do a Z transformation, put an equal sign, put Z transformation above the equal sign. And then again, look what I'm going to do. I'm going to copy down the P symbol. I'm going to copy down the parentheses symbols. I'm going to copy down the less than. And I have two spaces. I have to fill in those two spaces. Let's work on this space over here first. What goes there? Well, what was originally in that spot was an X. What you're going to do is you're going to copy down the X, and then I want you to write minus mu and divide the whole thing by sigma. That's what you memorize that. That's the Z transformation formula. Minus mu, divide everything by sigma. For the right side, for this spot over here, same thing. You're going to go and look and see what was originally in that spot, which was a 35. You're going to copy down what was originally there. Then you're going to minus mu and divide the whole thing by sigma. Okay. Next step. I'm still trying to change it to Z. For this last little bit, I'll have it changed to Z. The part that has the X, so this part here, this X minus mu over sigma, that whole mess, you just change it to Z now. It's just the Z. The right side, because the number 35 is there, I'm going to also plug in the numbers for mu and sigma. Mu is 30. Standard deviation is 7. Okay. And then you got to calculate that on the calculator. 35 minus 30 over 7. Let me do that real quick. Okay, now I have this long answer. Oh, okay, another thing to tell you. Whenever you're doing a Z problem, see, right, at this stage, we're at a Z problem. Inside the parentheses, the number has to have 2 digits after the decimal point. So you must round the number inside the parentheses if it has more than 2 digits. You have to round it. You have to round it correctly to exactly 2 digits after the decimal point. So that's the answer there for what goes inside the parentheses. So if it's longer than 2 digits, you have to round it to 2 numbers after the decimal. Make sure you round it correctly. Don't just write 0.7 because then you're going to look up the wrong number in the table. So one more time, when you do a Z transformation, the number in the parentheses next to the Z has to have exactly 2 digits after the decimal. If it has less, okay, that's fine. But if it has more, you're going to have to round it correctly to exactly 2 digits after the decimal. All right, at this point, we've changed the problem from a normal problem to a standard normal problem. And now the next step is to do the standard normal problem. I'll do it in a different color. Okay, so the red was like turning it from normal to standard normal, and now the blue is me doing the standard normal problem. You don't have to draw another picture for this. Okay, again, just one picture for the original question. You just got to do the z problem now. And how do you do a z problem when it's z less than? Well, those are the easiest ones. You just look it up in the table. So let's look at 0.71 in the table. Here's the table. We're looking for 0.71. It's positive. Use the positive side of the z table. 0.7 you're going to look for here. And then the last digit, 1 over here. And you go like this and like this. And the answer is 0.7611. Let's go to part B. Probably x greater than 18. Again, first thing you're going to do is you're going to draw a picture. Remember, there's a bag of numbers, and it's saying if you put your hand in the bag and draw one number out of the bag, we'll probably get a number greater than 18. All right, so picture. I'm drawing a normal distribution here. It's not the standard normal distribution, though, but they all look the same. But you put a dotted line here, and you put the mean here, which is 30, and we'll label it x distribution. Okay, then the number 18 is on the left of 30. So somewhere on the left of 30, I'm gonna put a tick mark with number 18 because it's less than 30, so it's on the left. And you go up to the curve. And which side do we shade? Which side of 18?
Right.
Shade to the right because it says probability x bigger than 18. You shade over the numbers that are bigger. You shade to the right. How far to the right? You go to the right forever. Okay, so at least in theory, the shading goes to the right forever. All right, so it's gonna be a couple more seconds to shade this. And then once you're done with the picture, well, is there any questions on the picture? Okay, so then the next thing is, this is a normal distribution problem. We're gonna turn it into a standard normal distribution problem by doing a z transformation. Again, only do a z transformation if the problem says that the variable is normal, but that's what it says, x has a normal distribution. So what do? You copy down the p symbol, you copy down the parentheses symbol, you copy down the greater than symbol, and you have to fill in the spaces. In the first space, again, what do you write there? Well, you look at what was originally in that space, the x, you copy it down, and then you minus mu and divide the whole thing by sigma, because that's the z transformation formula. Then for the second space, you do the same thing. Copy down what was originally there, which is the 18, minus mu and divide the whole thing by sigma. After you've done that, the part that has the x, this whole mess here, this x minus mu over sigma, that just becomes z. The other side, because we see the number 18, there's a number there. I'm going to plug in the numbers for mu and sigma. Mu is 30, sigma is 7. I'm going to calculate that. Okay, 18 minus 30, you got to do, and then get the answer, and then divide by 7. And again, I'm getting some long number on my calculator. You must round it to exactly 2 digits after the decimal. And you got to round it correctly. So negative 1.71 is what I'm getting there. And that's how you take a normal problem and turn it into a standard normal problem. We did the z transformation. Now that it's a z problem, now we have to do this z problem. Any questions to this point? So now, how do we do a z problem when it's a greater than? When it's a greater than, we have to use a formula. Someone tell me what the formula is.
1 minus a probability of z is less than negative 1.71.
Right. So again, whenever you have a probability z greater than something, use this formula, 1 minus probability z less than the number. The reason you do that is so we can use the table. I'm going to copy down the 1 and the minus. And now this less than, whenever it's probability z less than something, that's when you look it up in the table. So now we have to look up negative 1.71 in the z table. It's negative, so use the negative side. Negative 1.71. So you look for negative 1.7 here on the left and get the last digit from the top, and you go like this and like this. And that's the answer to that, 0.0436. And then we got to do 1 minus that. So the final answer, 0.9564. That's part B. Questions on part B? All right, let's do another one. I mean, we did a left one, a right one. Now we're going to do a between one. Again, there's a bag of numbers somewhere that has a normal distribution, mean 30, standard deviation 7, which again, that's describing the contents of the bag somehow to me. And now it's asking if you put your hand in the bag and draw a number out of the bag, what's the probability you get a number between 28 and 37? That's the question. So again, we're going to draw a picture first because probabilities for continuous random variables are areas. So we're going to draw the area this probability represents. So draw a normal distribution, put 30 for the mean and label it X distribution. The two numbers that are in the problem, 28 is less than 30. So you put a tick mark on the left of 30, put 28. 37 is bigger than 30. So on the right of 30, you put the 37. And you go up to the curve on both of those numbers. And because it's written like this, that means you shade between. Talking about between 28 and 37. So again, below the curve, above the x-axis, between these numbers. Okay, so you draw this picture. Any questions on the picture? So after you're done shading the picture, well, what do we have to do? This is a normal distribution problem. We have to change it to a standard normal distribution problem. So we're going to do, it's like a two-step problem. You change it to a z problem, then you do the z problem. So first things first, let's change it to a z problem using a z transformation. So the way you do it for a problem like this, for a between problem, well, you're going to copy down the p symbol, the parentheses symbols, and the two less thans. You copy them all down. And that gives you 3 spaces you have to fill in. Make this a little bit bigger. Okay, so we got to fill in those spaces. What do you put in the spaces? Well, you go and look and see what was originally there. Like in this first space, originally there was a 28 there. So you're going to write the 28 down again. But then you're going to minus mu and divide the whole thing by sigma. Do that for each space. For the middle space, originally there was an x. I'm going to copy down the x. But then I'm going to minus mu and divide by sigma. I'm changing the middle term. I'm transforming it. All the terms are changing. The last one, the space on the right side, what was originally there was a 37. We're going to copy down the 37. And you're going to minus mu and divide the whole thing by sigma. So I apply the z transformation formula to each of these pieces here, all 3 of them. Which one is the one that's going to change to z?
The middle one?
The middle one, the one that had the x will change to z. The other ones, I'm going to plug in the numbers for mu and sigma. So here I'm going to write 28 minus 30 over 7. This is the middle one turns into z. The last one, 37 minus 30 over 7. And when you're calculating a number inside the parentheses of a z problem, you must round it to 2 numbers after the decimal point. And again, you have to round it correctly, otherwise you're going to look up the wrong number in the table. When you do 2 divided by 7, this number here, on my calculator, I'm getting negative 2.8, negative 0.285 something. But if you round that correctly, it's negative 0.29 because the 8 goes up to a 9 because the next digit is a 5. Oh, sorry. No, I wrote it wrong. Negative 0.29. Again, it's on my calculator, it's negative 0.2857, whatever. But if you're rounding to this spot, if this number here, the next number is 5 or higher, you have to add 1 to that. So that's why it's negative 0.29. If this number is 4 or lower, you can just erase all this and write negative 0.28. Anyway, so that's negative 0.29. Again, round it correctly. The other number, 37 minus 30 over 7 is 1. You could just write 1, but I'm going to write 1.00 just to emphasize to you that the number has to have 2 digits after the decimal point. But again, if you just write 1, it's okay. But I'm gonna put 1.00. Then, well, what have we done so far? So we've changed the normal problem to a standard normal problem. Now our job is to do the standard normal problem. I'll do that in a different color, like it's the second part of the problem. How do you find a probability involving z if you're doing z between two things? Well, you can't use the table yet. You have to use a formula first to convert it into a bunch of less than so we can use the table. Someone tell me, apply the formula to this thing and tell me what the formula is.
Probability of z is less than 1.
Probability less than the number on the right minus what?
The probability of z on the right, the left,
Probability z what?
is less than.
Less than the number on the left. Yeah, they're gonna both be less thans. Yeah, probability z less than this minus probability z less than this. Okay, now why is that so much better? Because now this is a less than, this is a less than. We can look both of those up in the z table. Let's start off with the one on the right there, probability z less than 1. Because the number is positive, use the positive side of the z table. We're looking for 1.00. Again, you look for 1.0 and the last digit 0 over here. And the number is 0.8413 for that. 0.8413 minus. Now the other one is a negative number, so we have to use the negative side of the z table for that, negative 0.29. So looking for negative 0.29. Again, you can look for negative 0.2 on the left column. It's way down here, negative 0.2. Last digit 9 over here. And again, you go to the right. And you go down here and you get 3859 is what it looks like. 0.3859. That is this number here. And then you subtract those and that's the end of the story there. Okay, the answer I'm getting is 0.4554. Okay, questions on example 8. Okay, so pretty much the entire story of section 7.2 has been taught to you now. We're gonna do one more example. This example is a word problem, but this is the kind of problem you're gonna get on the exam. But it's it's basically what we just did, except there's a context. Example 8, we just had a bag of numbers. What do the numbers mean? They had no meaning. Now the numbers have a meaning. That's the only difference. There's still a bag of numbers. We're gonna draw a number out of the bag, but the numbers have a meaning. That's it. And that makes it a word problem. We got to write a lot of words to explain the meaning and all that to you. Let's go to read what it says. Pregnancy lengths have a normal distribution with a mean of 270 days and a standard deviation of 15 days. Okay, it says normal distribution. It has to say that to do the stuff that we're learning today. The Z transformation stuff, using the Z table, all that stuff. Okay, so pregnancy lengths have a normal distribution with a mean of 270 days and a standard deviation of 15 days. Before I continue, let me explain this bag of numbers that we have. I want you to imagine that every single time a baby is born, throughout time, all time, okay? Every single time a baby was born, as soon as the baby was born, the mother wrote down how many days the pregnancy was. So, they wrote, oh, my pregnancy was 250 days, mine was 272 days, mine was 291 days, whatever. So there's one, and they wrote it on an index card, and they put it in a bag. I want you to imagine a bag of index cards. Each index card represents some baby that was born at sometime, okay? And each number is a length of someone's pregnancy, okay? So the lengths of all pregnancies are in this bag. And they're trying to describe the contents of the bag. So they say the bag has a normal distribution, meaning, use some kind of curve like this to answer questions about that bag. The average of all the numbers in the bag is 270, standard deviation of all the numbers in the bag is 15. And now they're saying find some probabilities. Part A says, find the probability that a randomly selected pregnancy. What does it mean, a randomly selected pregnancy? It's like they're saying, we have this bag. If you put your hand in the bag and select one of those index cards, it's like a randomly selected pregnancy, okay? Lasts longer than 261 days. That the number on the index card is bigger than 261. Okay, so please remember, every probability problem, no matter how simple or complicated, you can really just think about it as we have a bag of numbers and we're drawing one side of the bag. Whenever they say you're randomly selecting something, we got a bunch of numbers in the bag, then we're going to draw something. But how the numbers get there, so that's why I explained. Every single pregnant time a baby was born, somebody wrote the length of that pregnancy on an index card and put it in a bag. We have this bag filled with gazillions of index cards, and we're going to draw one side of that bag. Anyway, and they're asking us for 3 probabilities here. So before we do the problem, a couple extra things you want to write in a word problem. You know how like in chapter 5, I would write, let A stand for this event, B stand for this event. And then I told you that if it's a word problem and if they don't give you letters, if they don't say, I'm using the letter A for this event, I'm using letter B for this event kind of thing, then you have to write it for me, right? So same thing when it comes to random variables. If they don't tell you what the random variable is, you have to write it for me. So we're going to start off by writing let X, we usually use the letter X for random variable, be the length. It's basically the number we get out of the bag. When you draw one side of the bag, X is that number, but I'm going to write down what the meaning of the number is. Let X be the length of a randomly selected pregnancy. It's probably only going to be worth 1 point on the exam when you write that, but the point is, I don't want you to lose that 1 point. So write it down, okay? So whatever the random variable is, write down what it is. So what's the number you get when you draw one side of the bag? It's the length of somebody's pregnancy. It's the length of a randomly selected pregnancy. Also, I'm going to write down that X is normal because they tell us it's normal. Pregnancy lengths have a normal distribution. That's what they tell us. And the mean is 270 days, and the standard deviation is 15 days. That's really all I need to write down to do this problem. And now let's go ahead and do the problem. Find the probability that randomly selected pregnancy lasts longer than 261 days. Okay, fine. A second thing you have to do is you have to write down the notation for the question. In example 8, they wrote the notation for you. Find the probability X is bigger than this, find the probability X is less than this, whatever. They don't have the notation written down here. They wrote it in words. The probability of a randomly selected pregnancy lasts longer than 261 days. Okay, so I need the notation for this. Can anyone give me the notation?
The probability that Z is greater than 261. X, my bad.
That's the length of the pregnancy. Probability X greater than 261. Yeah. Lasts longer than, that means bigger than 261. So it's like you draw an index card, you get a number bigger than 261. If you get it to there, the rest of it is like example 8. Okay, but just a couple extra things we had to get. We had to write the notation. Okay, now we're going to draw a picture. Mean goes here. The mean is 270, so I'm going to put 270 right here. I'm going to label this X distribution again. The number is 261. It's less than 270, so it's going to be on the left of 270. I'm going to go from there up to the curve. And because it says greater than, we have to shade to the right. You always draw one picture for the original question. Please don't forget to do that on the exam. If you forget to do it, it'll be 3 points. Because there's 3 questions I usually ask on this stuff. So 3 pictures, but it's not a lot of points. But I don't want you to lose the 3 points, so don't forget to draw the picture. Okay, now that I have the picture drawn, what are we going to do? What are we going to do? Someone tell me, what are we going to do?
Z-trans.
Yeah, so we do the Z transformation first. If you don't do it that way, you have another way to do it, it's possible you'll get points, but this is the way I'm teaching it to you. So immediately you change it from normal to standard normal. Immediately you change it from X to Z, doing Z transformation. So what you're going to do is you're going to copy down the P symbol, you're going to copy down the parenthesis symbol, you're going to copy down the greater than symbol, and you're going to fill in the 2 spaces. What am I going to write in the first space?
X minus mu Over sigma.
All over sigma. Okay. So again, whatever's there minus mu over sigma. What goes in the second space?
261
Mm-hmm.
minus mu over sigma.
Right. Whatever's there minus mu over sigma. Okay. Which one of those turns into Z?
The x.
The one that has the X, that thing I just circled, turns into Z. So it's going to be probability Z greater than. Now this side, I'm going to plug in the numbers because I already have a number there, 261. I'm going to plug in the numbers for mu, 270, and the number for sigma, 15. And we'll calculate that number. And again, when you calculate it, you have to round to 2 digits after the decimal. The answer is, the answer is negative 0.6. I'm going to write negative 0.60. You could just write negative 0.6, but I'm writing negative 0.60 to remind you that you always want to round a number inside the Z parentheses to 2 digits, to 2 numbers after the decimal. Okay, so we did the Z transformation. Now that we've done the Z transformation, now we have to do this Z problem. We have to figure out what this is. So this is like the second part of the work. Now what do you do? When it's a Z greater than, can you look it up in the table right now?
No.
So what do you have to do?
Start
Minus 1.
Yeah, you do the 1 minus formula, right? It's 1 minus. When it's a greater than, when it's Z greater than, you do 1 minus. What's the rest of it?
Probability of z is less than negative 0.60.
And then the Z less than, that you can look up in the table. So we'll look it up in the table. It's negative, so we use the negative part of the Z table. We're looking at negative 0.60, so you look for negative 0.6 on the left column, which is here, and the last digit 0 from here. You go to the right here, you go down here, and it looks like we get the number 0.2743. So that's this, 0.2743. And you got to do 1 minus that. 1 minus that, the answer is 0.7257. Okay, sounding good. Let's go to the next one, part B. Find the probability that a random selected pregnancy lasts between 267 days and 290 days. Okay. So what's the notation? But I can't draw a picture until I even know the notation. So let's get the notation first. So it's a probability. What's going to go in the parentheses?
267 less than x less than 290.
Okay. So again, this is the extra thing you have to do when it's a word problem and they don't give you the notation. You have to write down the notation. Okay. I will draw a picture at this point. Okay, so you draw some kind of bell curve, put the mean here, 270, label it X distribution. Okay, now I have to put these numbers in the picture. So 267 is less than 270. So it's like here. 290 is bigger than 270, somewhere here. It doesn't matter exactly where you put it, but one's on the left of 270, one's on the right of 270, so make sure you do that. Go up to the curve for both of them, and you're going to shade between, because this is the notation for between, or they're talking about between. So you shade below the curve, above the x-axis, and between these lines. Okay, so there's the picture for this one. All right, after you've drawn the picture, again, this is X, it has a normal distribution. So how do you handle problems that have a normal distribution? What do you do first? Other than the picture, what do you do first?
Z trans.
You do a Z transformation. Okay. And again, the way you do that is you're going to copy down the P symbol. You're going to copy down the parenthesis symbols. and the less than symbols. And we have 3 spaces to fill in. So what you do is, the first space here, you write down what was originally there, 267. So you just copy down the 267, and then you minus mu and divide the whole thing by sigma, because that's the Z transformation formula. For the second space, what do you put there? Well, again, you look at what was originally there, which is x, and you minus mu and you divide the whole thing by sigma. Minus mu divided by sigma, that's what you have to memorize. For the third space, same thing. You're going to copy what was originally there, 290. You're going to minus mu and divide the whole thing by sigma. After you do that, one of those terms is z. Which one is it? The left one, the right one, or the middle one?
The middle one.
Yeah, the one that has the x becomes z. That whole mess is now just z. And the rest of them, I'm going to plug in what the numbers are for mu and sigma. Mu is 270, sigma is 15. Same thing here, 290. Mu was 270, sigma 15. And now we're going to calculate those numbers. And again, you inside the parentheses of a z problem, you must round the numbers to exactly 2 digits after the decimal place. So this one here is negative 0.20. And this one is 1.33. And again, for the left one, if you want to just write negative 0.2, that's fine. But again, I'm putting the extra 0 just to remind you, they all have to have exactly 2 digits after the decimal. And again, if they ever have more than 2, you have to round it to 2. Don't round it to 1. Make sure it has exactly 2 digits after the decimal, and make sure you round it correctly. Now, we just took a normal distribution problem and turned it into a standard normal distribution problem. Now we're going to do the standard normal distribution problem the way we did it before. So I can't look it up yet, so I'm going to use a formula. And how does the formula go when z is between 2 numbers?
P of the z less than the second number minus P of z is less than the first number.
Right. And then both of those are less thans now, so you can look them up in the table. Let's start with this one, probably z less than 1.33. It's a positive number, so use the positive z side of the z table, 1.33. You look for 1.3 here, and the last digit 3 here. And you go like this, and you go like this. And it looks like we get 0.9082 for that. So that's this number here. Now the other one, again, it's a less than. We look it up in the table, and it's a negative, so we have to use the negative side of the z table, negative 0.20. Again, except for the last digit, you look for negative 0.2 on the left column. It's down here, and the last digit 0 here. And you go like this and like this. These lines look like they meet at 0.4207. That's this one, 0.4207. And then just subtract those. I'm getting 0.4875. Let me double check that. Yeah. And that's how you do part B. Okay, one last one. Let's take a look at this one. Because again, we did a greater than, we did a between, we got to do a less than. You know, all these problems, I kind of give you one of each, you know. So let's do this one. Find the probability the random selected pregnancy lasts less than 242 days. All right, notation. Someone give me the notation.
Probability of X is less than 242 days.
I don't write the units because it clutters up things. So I'm just going to write 242. But yeah, that's the notation. Okay, then picture. All right, so you draw some kind of curve like this, put the mean here, which is 270. One more time, label it X distribution. The number that's in the problem is 242. That's less than 270, so it's over here. Again, put a tick mark somewhere on the left of 270, write 242. go up to the curve, and which side am I going to shade?
The left.
The left, because it says less than, or it says less. You shade over the numbers that are less than 242. Those are the numbers on the left side of this line. That's the picture you draw. All right. So we have the notation, we have the picture. What's next?
Z trans.
You do a Z transformation. Let me say it one more time. Only do a Z transformation if the problem says, on the exam, if the problem says something has a normal distribution, that's the only time. Okay, if it's a binomial variable or a uniform distribution or anything else, you don't do this. It's only for normal. You're going to turn it into standard normal. Okay, so the way you do it is you copy down the P symbol, copy down the parenthesis symbol, copy down the less than. We got two spaces to fill in. What am I going to write in the first space?
X
X
minus.
minus over standard deviation.
X minus mu over sigma. What goes in the second space?
-42 minus mu over standard deviation.
242 minus mu over sigma. All right. Which one of those turns into Z?
X.
The one that has the X. Now that whole mess is gone and it's just a Z. So see, we transformed it to a Z problem. For the right side, 242, I'm going to plug in the mu, which was 270. And then sigma's 15. And we calculate that. Again, you have to round that to two numbers after the decimal. So let me get my calculator out. So 242 minus 270, you get the answer, divide by 15. Okay, I'm getting negative 1 point. Okay, so it's negative 1.86, a lot of sixes. You have to round to the two numbers after the decimal, but because the next one is bigger than 5, you have to add 1 to that 6. It's going to be negative 1.87. Okay, so you got to make sure you round it correctly. If you just erase this and write negative 1.86, you're looking up the wrong number. Okay, so we took the normal problem and we transformed it to a Z problem, to a standard normal problem. So the X problem is now a Z problem. Now we do the Z problem. So I'll change color for the rest of it. But it's already a less than. When it's a less than, those are the easiest Z problems to do. You just look up the number in the table. It's negative, so I'm going to use the negative side of the Z table. We're looking at negative 1.87, so let's go look it up. So negative 1.8, you get from the left column. The last digit you get from the top. And you go to the right of the negative 1.8. And you go down from the 0.07 until these lines meet. Looks like they meet at 0.0307. That's it. And that ends example 9. Okay, so guys, that is the end of the story for today. Our lecture is done.